you cannot move an inch in physics without talking about these things, which are called units and measurements. And some measurements, some units are called fundamental, some units are called derived units. There are different systems in units. Some international systems, some things called international systems, some things called imperial systems, which we use in the US. And there are ways you can convert from one system to another system and one unit to different unit in the same system. So we're going to be talking about all of that. And first of all, let me just start by saying what we mean by measurements. So think of, like, you know, you have heard these things where someone says, oh, well, a whale is the heaviest mammal or animal in the planet Earth, and it weighs about 5 school buses. So, you know, like, it's a good comparison if you know how much a school bus weighs. But irrespective of that, if you have a sense of how much that weighs, you know that if it's 5 times of that, that is how much a whale weighs. Now, physical quantities like weight, time, length, these things are called fundamental quantities, and these are measured into something called units. Okay, and it's perfectly fine as long as everyone understands how much one school bus weighs, to use something like this is equivalent to, let's say, 5 football fields or this or that. But it is not very scientifically, let's say, effective. Okay, so to have more understanding of what a scientifically effective unit is, we'll introduce things like meters and centimeters and things like that. So there are some physical quantities always in physics that we want to measure. Okay, and then you do these measurements. For example, the weight of something, or how long is something, right? So those things are called physical quantities, and there are some fundamental physical quantities and then some are derived physical quantities. Okay, I'm going to tell you what fundamental physical quantities are. Fundamental physical quantities are length. Okay, let's call this L. Mass, let's call it M. Time, okay, that's capital T. And electric current, that let's just call it I. Now, if you're watching this video and you want to do mechanics, okay, whether it's 211 or whatever it is called, you would probably not be talking about current, but you will definitely be talking about length, mass, and time. Now, as I said, these are physical quantities, okay. Now, the other quantities, for example, let's say distance, or let's say velocity, it is a derived quantity. Or speed, it's a derived quantity, which is distance or displacement over time. So that means the length over time is the speed or velocity. So that unit of that, I'm sorry, not the unit, but that physical quantity, that is the velocity or the speed, is a derived physical quantity. Now, these physical quantity are measured in terms of what we call units. Okay, so you can measure, you can give a sense of length to someone by measuring or by saying that this is how it is. Like this like you weigh 80 kilograms. That means that if you take 1 kilogram of something and then you take 79 more of that thing, then the weight of that thing is the same as your weight. If you say someone is weighing 80 kilograms, right? So you say you give a sense of these physical quantities in terms of something that is called units, and we all know what those things are. For example, if you're driving a car in US, you're probably driving in the 25 miles per hour limit if you're in the city. So that means you cannot go beyond, you cannot travel more than 25 miles in 1 hour in the average sense. So units, let's just write down what fundamental units are and what derived units are, right? This is just as we have physical quantities, which are some are fundamental, for example, length, mass, time, and current, and some are derived. For example, those things can be explained or written down in terms of fundamental physical things. So in units, you have got fundamental units. Well, before even saying that, let me just say something else. There are two types of systems that we use in this world. One is called SI system, which is in English means international system, but in French I'm not going to even try to pronounce it. It means the same thing, but it is an abbreviation of the two French words, which means international system. So that's why you have SI instead of IS. And this system is also called international unit of system, because most of the countries, I think, except the US, every other country in this world has like taken notice of how much this makes sense in certain ways, so they have accepted this system as their working system. So international system, SI system, and some other people also call this metric system. And then there is something called imperial system or English system, and this is followed in US. Now let me tell you, this is really incorrect. People make fun of like Americans make fun of the other world, the rest of the world, and the rest of the world makes fun of the Americans because they use these units. But let me just say this. I have asked people how much is their height in America, and they have always answered me in centimeters, and that is definitely not imperial. And in India, where I'm originally from, there are like carpenters who make stuff for you, and if you ask them, if you tell them these things, I want this table and its width should be 1.2 meters, they'll probably be like, what? Because they don't use meters, they use inches and feet. So I'm just gonna say most of the world is hybrid. Definitely it's more hybrid in India as compared to the US, but yes, most of the world is hybrid. So imperial system and SI system. Now, when you do physics, it is internationally accepted and everyone agrees that you better be using international unit or metric system. Okay, so in metric system or international units, there are fundamental units again, right? So we have got fundamental quantities which will be written down in terms of these things called units, and then there are some fundamental units, and then there are some derived units. So fundamental units, and you've got derived units. So fundamental units, well, I said for mass in SI, okay, remember I'm only talking about SI, is meters or a small m. For time, it's seconds or s. And what is the other one? Mass, time, length. If you want to measure length of something in international system, you give it in terms of oh, okay, meters definitely for length and not for mass. Mass is kilograms or kg, and current is in amperes. Okay, and derived units would be units which can be expressed in a combination of fundamental units. For example, let's say speed. Speed is distance over time, or length over time, or in SI would be meters per second, right? So this is a derived unit. Charge, for example, charge per unit is current, so you can say charge is current times the time, right? So that would be a derived unit, charge. Now, one thing is also important here is that some fundamental units are more fundamental than others, because current, for example, is it can be understood as charge per unit time, but if you look up in your book, you'll see that the definitions of mass, time, and length are really detailed and really exact. So those units, I'd say, are more fundamental than, let's say, the unit of current, that is amperes. Now, we've talked about units, we've talked about measurements and why these things are important. I'll give you one example, again, to just recap the whole situation, why units are important, is that if you ask me, how much do I weigh? And I say, I weigh 170. Okay, if you're in the US, and just from the common sense, it's perfectly fine to assume that I mean 117 pounds. But there's no reason, and someone would be incorrect to ask me a follow-up question, 170 what? Well, if I weigh 170 kilograms, it's completely different than if I weigh 170 pounds. So that's why units are important.